Hello, sixth grade. Today you are going to need graph paper and I'm going to use a pen so I can show you, but pencil is probably a better idea. So get that ready and then come back. All right, so I've turned my paper horizontally so that I have enough room here, but we're going to draw a number line and make it fairly long across your paper. And I'm going to kind of find the center here and label it 0, okay? And then what we're going to do is we're going to count 10 spaces, okay? So this would be a space. That would be 2, 3, 4, 5, 6, 7, 8, 9, 10. And after the 10th one, I'm going to put another line, okay? And then we're going to do the same thing in the opposite direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll put a line there and we'll label this -1. Okay, so now you can see that we have lots of parts and we're going to label the parts. All right, so now you notice that when we counted, we didn't count lines, we counted spaces, because the lines indicate where you put the value, but the space represents the amount of room that value needs. So if we have 10 spaces, each one of them would be 1/10. And so I'm going to write 1/10 on the first space. And I'm doing it on that line. So that is the fraction form of 1/10. And below the number line, I'm going to put the decimal form of 1/10. And I guess we could put a little mark there. It is the first out of 10 equal parts. Okay, now what I'd like to do is label all the decimals first, and then we'll go back and do the fractions. So the next space would be 2/10, and I'm kind of going up and down with my values because otherwise I don't have enough space. The next space would indicate 3/10, and then we have 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and then you notice we get to 1. I forgot to label 1. 1, if we kept counting by tenths, would have been 10/10, right? 10 divided by 10 is 1, so it's just another way of saying 1. 1's a more efficient way of saying that value rather than 10/10. Okay, so now what we want to do is we want to put the fraction equivalents above the number line. Now, we want the fractions to be in their simplest form. So we could, if you think about the way these decimal numbers are said, the fractions are said the exact same way as a starting point. So we could say 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, right? But not all of those are in their simplest form, and we always want to use fractions when we're labeling, for instance, this in their simplest form. Now, there are times we want to use fractions in a form that's not simplest, but this is not one of them. So let's think about, of those fractions, which ones are in simplest form? 2/10? No. 3/10? Yes. So we could label 3/10 in fraction form above 3/10 in decimal form. 4/10 is not simplest form, 5/10 is not, 6/10 is not, 7/10 is. So we can label 7/10 above 7/10 in decimal form. 8/10 is not simplest form, but 9/10 is. Okay, so now our goal is to label the other fractions with their simplest form. So I'm going to ask you to pause the video right now and see if you can do that on your own, and then we'll come back and check. All right, so I've added in the fractions that needed to be simplified. One pattern you might have noticed is that the first fraction that needed to be simplified was 2/10, which simplifies to 1/5. The next one was 4/10, which simplifies to 2/5. Do you see that pattern there? That the fifths are the simplest form of some of the tenths. So we have every 2/10 is a fifth. So 2/10 is 1/5. 4/10 is 2/5. 6/10 would be 3/5, and 8/10 would be 4/5. So there's that relationship between fifths and tenths because 5 is a factor of 10. The other one then is 1/2, which is the same as 5/10. Okay? Now what we want to do is label the opposites on the other side of the number line. So the negative opposite of these positives. So again, pause the video and then see if you can get that done on your own. Okay, so what you hopefully noticed is that just like when we plotted integers on a number line, when we plot rational numbers that are negative, they are exactly opposite of their positive opposites, right? So if we counted 1/10, 2/10, 3/10, 4/10 in order from least to greatest, on the negative side of the number line, quantities less than 0 go in the opposite direction. So from when we're going backwards, we're counting -1, -2, -3 in a negative 1/10, I should say, -2/10, -3/10, but that's now going greatest to least. So just like with integers, it is the opposite of what you find on the positive side of the number line. Okay? Hope that makes some sense. So there are two fractions that are very commonly used, 1/4 and 3/4, that are not on our number line, and I'd like to place them on our number line. So the question is, where do they go? And the easiest way to order fractions is to think of them as decimals, because decimals make more sense least to greatest. Fractions, when you have all those different size parts, size denominators, is a little tricky. So either you want them all to have the same denominator or create them, convert them all to decimals and then order them least to greatest. So let's think about 1/4 in decimal form. Now the easiest way to think about 1/4 is if you have 4 parts, that's what 1/4 means. And we wanted to make it a decimal. Anytime you want a decimal, you want tenths or hundredths or thousandths. Well, we know that 4 is a factor of 100, and we know that it takes 25 fours to make 100. So an equivalent fraction would be 25 hundredths, which we could then put in decimal form as 25 hundredths. All right, if I wanted to do the same thing with 3/4, I could. I could say, well, it takes 25 fourths to make 100, so 3 25s is 75, and 75 hundredths as a fraction can be written as 75 hundredths in decimal form. So now we can place this on our number line. So 25 hundredths is going to be halfway between 2/10 and 3/10. Now, how do we know that? We know that we could place a 0 in the hundredths place and not change the value of those decimals. 2/10 and 20 hundredths are equivalent. 3/10 and 30 hundredths are equivalent. So 25 hundredths would go halfway between the two of them. And then if I wanted its opposite, I would go the other direction from 0 and do the same thing. This is -20 hundredths here. This is -30 hundredths, and -25 hundredths would be halfway in between -25 hundredths, which means the fraction of -1/4 could also be added at the top of the number line, just like over here we could add 1/4. So you can see that 1/4 is greater than 1/5, but less than 3/10. So let's do the same thing now with 75 hundredths. Can you place it on the number line? Pause the video and see what you can do. Okay, so 75 hundredths would be halfway between 7/10 and 8/10. And I could label it as 3/4 above the number line. And then its opposite would be greater than -8/10, but less than -7/10, halfway in between. And again, we could put the fraction above the number line. -3/4 is greater than -4/5. Okay, so let's try converting these decimals into simplified fractions. And so really the easiest way to do it is to say the number and write it in fraction form exactly like it sounds. So this first one is 35 hundredths. We're going to write it just like it sounds. Now, you might notice that 35 and 100 both share a factor of 5, and you know that because in the ones place, there's a 5 and there's a 0, and that's two of the criteria for being divisible by 5. So we can divide this by 5/5. So really 5/5 is the same as 1 whole. So we're dividing 35 hundredths by 1, which is still going to equal 35 hundredths. It's just going to take a different form. So we're going to divide the numerators. 35 divided by 5 is 7, and 100 divided by 5 is 20. And so 7/20ths would be the simplified fraction equivalent to 35 hundredths in decimal form. All right, try that now with the next 4 decimal numbers, and then come back and check your work. All right, so take a look at the correct answers and see how you did. All right, so I would like you to try some problems on your own on page 62, 1 through 21, and we will check them on Monday in class. Good luck.